Students, welcome to lesson U1A04. In this lesson, we will talk about midpoints and the distance formula and how to apply the midpoint formula and the distance formula to solve problems. So let's take a look. In this lesson, you will be needing to use these two formulas here, the midpoint formula and the distance formula. Now, the best way to remember the midpoint formula is simply that the midpoint, a synonym for midpoint or the midway point, okay, is the average. So to find the average between two things, between two numbers, between two parameters, okay, is to add up those two numbers and then divide by 2. But we have to do this both in the x direction as well as in the y direction. That is the best way to remember this, that the midpoint is the average between 2 points. The second formula we're going to look at is the distance formula. And the distance formula is given by this long and abstract looking thing. Okay, it is the square root of x2 minus x1 quantity squared plus the difference between y2 minus and y1 quantity squared, square root. So rather than remembering that long equation, another way of thinking about it is simply finding the square root of the change in x squared plus the change in y squared. And then a third way of thinking about it is the distance formula is simply the Pythagorean theorem. Okay, it's the Pythagorean theorem where I have a squared plus b squared, a squared. Whoops, I did not mean to use a highlighter. So it is simply a squared plus b squared equal to c squared. However, the quote-unquote distance, okay, that we're trying to look for here is the hypotenuse. So c is equal to the square root of a squared plus b squared. Okay, where a is the horizontal change and b is the vertical change. So that is the way to remember it, rather than having to remember that the distance formula is actually this long-looking thing. Okay. All right, so let's take a look at some examples. So the first example we're going to look at is to find the midpoint between 2 points that are on a number line. So this number line here, I have the x-coordinate is -3 and then another x-coordinate is 12. So how do I find the average between these two, or the midpoint between these two, right? Because that's essentially what it is. The midpoint is, in fact, the average. I will need to add up -3 and 12 and divide by 2. Last I checked, if I add -3 and 12, I will get 7. 7 divided by 2 is just 7 divided by 2. The beauty with working with fractions is I don't have to care about leaving a fraction in any form. Like, I don't need to convert it into anything else. The only thing I really need to do is just try to reduce that fraction. But it's 7/2. If you don't like working in fractions, you can also work in decimals if you wish, okay? But it's all the same. But I encourage you to get comfortable working with fractions, just because that is it's sort of like an expectation, okay, that you do get more and more familiar with it as you get older, as you move on to higher level, more complex, more abstract mathematics. So it is 7/2. The next problem that we're going to look at is we're going to find the midpoint between points A and B, and additionally we're going to try to find the distance between points A and B. So to do this, just like I've said before, to find the midpoint, it is simply the average between 2 points. So recall, if you please pause the video now and try to attempt this. The last I checked, right, the midpoint formula was this: x1 plus x2 divided by 2, y1 plus y2 divided by 2. Pause the video now, okay, and see if you can apply that, okay, perform a direct substitution. I would also encourage you to label this as x1, y1, and this is x2, y2. Please perform the substitution and try to solve for the midpoint. Go. Welcome back. So hopefully everyone was able to perform the correct substitution and be able to apply the midpoint formula and have it be reduced down to this value of 3,5. All right. So the next thing is we got to figure out what the distance is between A and B. And yes, we can still continue to say, oh, x1, y1, x2, y2, and apply it to this big formula. x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and then take the square root of that whole thing. We can certainly try to do that. Or alternatively, we can construct a right triangle out of this and then try to figure out what the hypotenuse is using the Pythagorean theorem. Notice if I just count squares, the horizontal change, the delta x here, the delta x is 4. The vertical change is 2. Delta y is 2. So again, according to a squared plus b squared is equal to c squared, right? Where c now is our hypotenuse, that's really the length of AB, right? This is 2 squared plus 4 squared is equal to c squared. Or c squared is equal to 20. You can certainly leave your answer as c is equal to square root of 20 because we need to take the square root of both sides. However, in all the standardized exams that you'll ever encounter in your lifetime, you will be expected to know how to reduce the square root. So square root of 20, you need to look for a perfect square that divides evenly into 20. And if you're thinking of the number 4, you're right. Square root of 20 is the same thing as square root of 4 times square root of 5. However, square root of 4 is in fact 2. So this is 2 square root of 5. So the length of the hypotenuse is 2 square root of 5, or the distance between AB, points A and point B, is 2 square root of 5. All right, which brings us to this question. We now need to find a midpoint between points A and B, okay, such that M is the midpoint. And M here, you're told what the midpoint is. The midpoint is 2, 1. You're also told that point A is negative 4, 5, and you're asked to find out what point B is. So in other words, you're told the midpoint. You are told one of the points, okay, to which the midpoint will be at 2, negative 1, but you need to find out what the other point is, the other endpoint, okay? So how are we going to approach this? Well, the way that I find that is most useful here, in an algebraic sense, okay, you can certainly try to solve this using the formula x1 plus x2 over 2, y1 plus y2 over 2. And you know, because we're trying to look for this, I'm going to call this my x2 and y2, and I'm going to call this my x1 and y1. So check this out. If I plug in negative x1 is negative 4 plus x2 divide by 2. This gives me the x-coordinate, okay, of the midpoint. Wait, what's the x-coordinate of the midpoint? Oh yeah, it's this guy right there. This is going to equal 2. From here, I can solve for what x is. I'm just going to quickly set up the y component. So if I put in y1, which is 5, whoops. If I put in y1, which is 5 plus y2, I don't know what that is. I'm going to call that y2, divide by 2. I know that that will equal to the y-coordinate of the midpoint. And as it turns out, that is negative 1. So I'm left with 2 algebraic problems that I need to solve. I'm going to cross multiply, and then I can figure out what x2 is. And same thing for y2. If I cross multiply here, multiply both sides by 2, I will end up with negative 4 plus x2 is equal to 4. Add both sides by positive 4, I will end up with x2 is equal to 8. Similarly, if I do the same thing over here where I try to find out what y2 is, y2, if I multiply both sides by 2, I'll end up with 5 plus y2 is equal to negative 2, sorry. And then if I subtract both sides by 5, I'll end up with y2 is equal to negative 7. So what exactly is the point are the coordinates for point B? Well, B must be 8, negative 7. And that's it.